What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we are going to tackle data science interview questions number 40 up to number 47. So without any further ado, let's get straight into it. Now, data science interview question number 40. What can be done about outlier values? So, using univariate or any other graphical analysis method, outlier values can be found. If there are few outlier values, they can be evaluated individually. However, if there are enough, the values can be substituted with the 99th or first percentile values. Outlier values do not include all extreme values. The most frequent methods for dealing with outlier values are: number 1, to adjust the value and bring it inside a certain range. Number 2, simply removing the value. So oftentimes when guys, if you are faced with data that has few outlier values, oftentimes the most feasible thing to do would be to just remove that value. Okay, so that's what we have there. Now on to question number 41. How can you assess and tell if a logistic model is good? Okay, so logistic model alludes to a logistic regression model. So remember, it is a classifier. Okay, so the following are some approaches for evaluating the findings of logistic regression analysis. So we have examining true negatives and false positives using the classification matrix. Concordance aids in determining the logistic model's capacity to distinguish between events that are occurring and those that are not. Lift assists in the evaluation of the logistic model by comparing it to random selection. So those are three interesting ways, guys, that can be used to assess the kind of performance of a logistic regression model. So data science interview question number 42. Explain the Box-Cox transformation and how it is used in regression models. So the response variable for a regression analysis may not satisfy one or more of the assumptions of an ordinary least squares regression for many reasons. The residuals could either follow a skewed distribution or curve as the prediction rises. In such cases, the answer variable must be transformed so that the data meets the needed assumptions. A Box-Cox transformation is a statistical method for transforming non-normal dependent variables into normal shapes. Most statistical procedures presume normality even if the data is not normal. When you use a Box-Cox transformation, you can run a larger number of tests. So we have a mathematical equation here, guys, for the Box-Cox transformation. Now, on to data science interview question number 43. Is it possible to use Microsoft Excel to perform logistic regression? Microsoft Excel may be used to do logistic regression. Excel can be used in two ways to do this. Number 1, one option is to employ add-ins given by a variety of websites. Number 2, the second option is to design a logistic regression model using the foundations of logistic regression and Excel's computing power. When this question is posed in an interview, the interviewer is searching for a strategy that uses the basic Excel functions rather than the name of add-ins. To understand logistic regression in Excel, we'll utilize some sample data. This example assumes that you understand the fundamentals of logistic regression. So I've taken the courtesy, guys, and I went on to basically provide us with an informative kind of demonstration of how logistic regression can be imposed or actually implied in Microsoft Excel. So the above data is made up of three variables, x1, x2, and y, which are independent variables, and y, which is a class variable. For the purpose of our binary logistic regression classifier, we have only preserved two groups. Next, we will make a logit function using independent variables such as logit is equals to L is equals to b0 plus b1 multiplied by x1 plus b2 multiplied by x2. So for the time being, we've left beta 1 and beta 2 at 0.1 and we'll utilize Excel solve to optimize the beta values to maximize our log likelihood estimate. Assuming you are familiar with the fundamentals of logistic regression, we can calculate probability values from the logit using the formula probability p is equals to e to the power logit all over 1 plus e to the power logit. E is equals to 2.71828163. It's basically the basis of the natural logarithm. Let's put it into an Excel formula to figure out the probability values for each observation. The chance of predicted y given a set of independent variables x is known as conditional probability. This can be calculated as follows, and we have a formula. Then we must take the natural log of the function above, which is basically this, which as it turns out is this. The log likelihood function is a function that calculates the probability for all observations. LL is the sum of the above equations. Now guys, just as a side note, right, when it comes to machine learning probabilities, to be honest with you, the most, I would say, efficient probabilistic machine learning equation that you can familiarize yourself with, and you should familiarize yourself with, is the naive Bayes equation, okay, or the naive Bayes algorithm. That is something that I highly recommend you to learn as well as you can. It will pay off and it will benefit you, okay. As always, you guys should know I intend to have tutorials pertaining to all those topics on the channel, but as I mentioned in a previous video, only as time goes on will I be able to proceed with those tutorial series. So anyway, the total of column G, which we just calculated, will equal log likelihood LL. So that is fine. The goal is to maximize the log likelihood, which in this case is cell H2. We must optimize B0, B1 and B2 in order to maximize H2. We'll do the same thing with Excel's solver add-in. This add-in is pre-installed in Excel and can be found under the data tab. If you don't see it, double check that you've loaded it. To install an add-in in Excel, follow these steps. So these are steps that I've added for you guys in case you don't have the solver add-in already pre-installed. By default, it should be included in your Excel installation. If not, I have these steps for you guys. So you can check if the checkbox in front of the required add-in is checked or not by going to File, Options, Add-ins. If you want to load an add-in into Excel, make sure you tick it. Number 2, go to the bottom of the screen, Manage Add-ins, and click OK if you don't find solver add-in there. Following that, you should see a pop-up window with your solver add-in present. Check the box next to the add name. Add names ins. Well, it should have been add-in's name. Anyway, if you don't see it there, click browse and navigate to the needed folder where solver add-in is located. Number 3, once you've loaded your solver, click on the solver icon under the data tab to bring up a new window that looks like this. So these are steps. It's not necessary for me to read it for you guys, but I am doing so anyway. It's part of my duty. So fill cells E2 to E4 in the next form by putting H2 in a set objective, selecting max and filling cells E2 to E4. We've informed solver to maximize H2 by adjusting the values in cells E2 to E4 in this way. Now, at the bottom of the page, click the solve button. A window will appear as seen below. And we see this. This indicates that solver has discovered a local maxima solution, but we require global maxima output. Continue to click continue until the pop-up below appears, which is basically this window here. Now, it demonstrates that solver was successful in locating and finding the answer. It will produce an error if it is unable to converge. To accept solver's solution, select keep solver solution and then click OK. The values of the beta coefficients from B0, B1 and B2 have now changed, and our log likelihood function has been maximized. So that is basically what we have here, guys. We have B0, B1 and B2. Values have been assigned to them, if you will see in column E. And by determining the probability cutoff, you may compute the probability and thus the response variable using these beta values. So that is what we have there, guys. Just to refresh you, this is how we implement logistic regression in Microsoft Excel. Okay, so data science interview question number 44. How do you calculate statistical power of sensitivity? So the accuracy of a classifier, logistic, SVM, RF, etc. is frequently validated using sensitivity. Predicted true events over total events is what sensitivity is all about. True events are those that occurred and were predicted by the model to occur. The formula for calculating sensitivity is simple. Sensitivity is equals to true positives divided by positives in actual dependent variable, where true positives, on the other hand, are positive events that are appropriately characterized as such. So that is what we have there. Now, data science interview question number 45. Give examples of when you would use an SVM instead of a random forest and vice versa. SVM alludes to support vector machines. So, in classification tasks, both SVM and random forests are used. Number 1. Use SVM if you are confident that your data is outlier free and clean. The contrary is true. If your data contains outliers, random forest is the best option. Number 2. In general, SVM uses more processing power than random forest. Therefore, if memory is a concern, use the random forest machine learning algorithm instead. Number 3. Random forest provides you a very good concept of varying importance in your data. Thus use random forest as your machine learning method if you desire variable importance. Number 4. For multi-class issues, random forest machine learning methods are preferred. Number 5. In multi-dimensional problem sets such as text categorization, SVM is favored. But as a good data scientist, you should experiment with both and test for accuracy, or you can employ an ensemble of multiple machine learning approaches. So that is what we have for question 45. Now, on to number 46, guys. In R, how are missing values and impossible values represented? So the symbols NaN, not a number, and NA, not available, are used to signify impossible values and missing values respectively. The simplest way to respond to this question is to say that deleting missing numbers is not a good idea because the missing value could be due to a fault with the data collection process, programming, or the query. It is a good idea to figure out what's causing the missing values and then take the required actions to address it. So, as you guys can see, there is a small definition of NaN and Na. So you guys can read through that. You can pause the video and do so. So, let us move to the last question, 47, for this video. The R programming language includes the CRAN, C-R-A-N. How do you logically decide which is the most appropriate package or packages to use for your program? So CRAN, you guys know, if the interviewer asks you what CRAN stands for, then you just should say it's basically the Comprehensive R Archive Network. So there are around 6,000 packages in the CRAN package ecosystem. Beginners should respond to this question by stating that they are looking for a package that follows solid software development standards. The next step would be to seek user evaluations and see if other data scientists or analysts have solved a challenge comparable to yours. So that is all for this video, guys. I hope you guys found this video interesting. Thanks for watching. Thanks for staying till the end of the video. Good luck with your work, and I will see you in the next YouTube video.